So we wanted to calculate how much flow of water under a bridge. And project 2 is there. You should have the instructions. If not, you can go to Blackboard and get it. This is what it is. I've drawn here what the schematics look like. So we have a watershed that has been subdivided in 4 sub-watersheds and 2 reaches. And you could have done that with our GIS as the project designer. So here's our bridge, here's our watershed, and we subdivided in 4 sub-watersheds, and we have 2 reaches. Our final goal is to come up with a design flow here for a given return period under this bridge. Is this clear?
Yep.
Okay, so in the project description here, I'll give you some data for those sub-watersheds and bridges, so you can set up your project. So the first thing we want to do is to set up a model that would represent this. And we'll do that using HMS, Hydrologic Modeling System, from the Army Corps of Engineers. It's free, you can download it online. I'll Google and show you right now. I'm not sure if I've done that. So if I Google HEC-HMS, it's the first thing that shows up. And here it is. So here's where you can come. This is what it looks like. Downloads, documentation, no issues if you run into issues. There's a bunch of releases here. You want to go with 4.1. You get it. All of those computers in the lab have it already. So no need to download if you're there. Okay. So once we set up a model, we want to calibrate that model. What do I mean by calibrating the model? You want to compare your results to measure data to see if they make sense. Otherwise, how can you believe that you're representing this properly? Once we're kind of confident in our model, we're going to calculate our design for a given return period. Once we're done, we could have gone home here. If not, that land use in the watershed has changed. So we're going to change that land use and we're going to rerun the model to see what's the impact on our design. Does this make sense? Yes, at this point? Okay, so how would we calculate flow here based on what we've learned so far?
Runoff.
Rainfall runoff. So this is like exam 2 review, because we're going to start with precipitation, and we're going to calculate runoff per sub-watershed, and we're going to do flood routing in the reaches to come up with a hydrograph. So literally what we want to do here is we want to put precipitation falling in here, and we're going to calculate runoff. So here, at this point, we want to get a hydrograph, right? Same thing at this point, we want to get a hydrograph. So the hydrograph starting on this ridge is the sum of these 2 hydrographs that will be routed through reach 1. But watershed C is also producing a hydrograph that's coming in here. And then what's coming into reach 2 is this hydrograph plus those 2 hydrographs that were routed to reach 1. And then on reach 2, we will have this hydrograph plus those that will get to your bridge, plus the contribution of this little watershed towards here. Did it make sense what I just said? This is the key here. Okay, great. So we're going to use a model to represent this. Okay? Wow, that was much easier than I thought. Okay. So we're going to start HMS. I shouldn't have HMS somewhere here. Here it is. Should I put lights off? Or this is clear enough? What? Fine? You guys want to come closer or you're fine? Can you see it? You're good? You can see it. Yeah? All right. Okay, so this is how you start. From scratch, the first thing you're going to do here is start a new project. And I'm going to call it class demo 2. And you want to save it in somewhere where you can find it. you're gonna choose your unit system. We're gonna use US. So I just say create, it creates me a project. At this point, there's no much going on here. The next thing we wanna look at is the components. Components are the basic ingredients to your model. So there are a bunch of components here. We will be using the basic model manager, which will create and represent the watershed. We will use a meteorological model, which will be forcing our model. We will use time series data manager because we're working with time series for rainfall and river flow. And we will have a control specification manager, which will be used to set up a run because we're running this model over time, so we need to put this run together. Okay, so Bayesian model manager, new, Bayesian one, I'm happy with that name. Okay, now I have a Bayesian model. I'm gonna open it, I'm gonna click on here. I get my Bayesian model. It's empty, but it also opened it up my Bayesian components. Those are the ingredients we have to come up with this. So we will basically use this guy, which is our sub-Bayesian. So there's a little drop and an arrow going down. It's called sub-Bayesian creation tool. How many sub-Bayesians do we have?
4.
4. So I have this one, it's called sub-Bayesian A. I have another one here that's called sub-Bayesian B. We have one more that's called sub-Bayesian C. And we have a fourth one that's called sub-Bayesian D. All right, they're just hanging in here for now. We'll also need this one. It's called the junction creation tool. There's a bigger arrow. Not sure how to describe it. It's the fourth thing here, this guy. Junction creation tool. We will need a junction to put these two hydrographs together. We will need a junction to put those hydrographs together. So we need 2 junctions. So I'm going to add a junction here. I'll call it junction 1. I don't care. And I have another junction here. I'll call it junction 2. We also need a sink. Here's the sink. And one that has water coming in, nothing going out. Sink. I'll call it sink 1, but we could have called it bridge. That would have been a better choice. Because the sink is literally a sink. It's collecting all the water that's coming out of your watershed. What are we missing?
Reaches?
Reaches, the actual rivers. So we have 2 of them, right? So reaches are this guy, the second one. Reach creation tool. So reach 1 and reach 2. Okay. So I have my basic components here. Yes?
Yep.
Next step we're going to do is we're going to connect them. And here's where a lot of people make a lot of mistakes. So the first thing you have to think about is putting your components there. The next thing is to connect them. The way to connect them is we're going to expand the Bayesian so we can see them all. And as we click on these guys, we get a lot of options. And we're going to work through these options, but the first thing we want to look at is the downstream option. Downstream none means, so Bayesian 1A is not connected to anything. Where should it be connected to downstream?
Junction 1.
Junction 1, there you go. So here it is. So Bayesian B should be connected to?
Junction 1.
Junction 1. What else? So Bayesian C should be connected to?
Junction 2.
Junction 2. So Bayesian D should be connected to?
Sink.
Sink. There you go. Now my reach also needs to be connected. So reach 1 should be connected to?
Junction 2.
Junction 2. And reach 2 should be connected
Sink.
to? Sink. What are we missing to connect here?
Junction.
Junctions. Junction 1 should be connected to,
Nope,
Reach one.
one.
and junction 2 should be connected to
Reach. Oh, yeah,
reach
reach
2. Right? Yes?
Yeah.
Where did you go to get the basin models? Is that on the components?
Yes. The components will start a basing model manager. You say new, it gives you this window.
Okay.
Once you have this window, you're adding the components up top. Those guys. You're adding then those guys. What am I missing?
The black arrow.
Are we good? Are we happy with this representation of this? Yes? Or no? Well, that's coming up. So the first thing we want to do is to represent the system well. We want to make sure your system is well represented. The next step is going to be to add data to the system. Okay? So troubleshooting, make sure that this is well represented there. That's the #1 source of mistakes as you move through it. Did you see how I did it? Downstream, 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 all of that? Okay. So literally next, what we're going to do is we're going to go through each component, and we're going to add the methods and the data parameters needed to solve those methods. Okay? So I'll start with subbasing A. And then here it is, my subbasing A. On this window here is where I can define everything that goes in subbasing A. So in this case, it's asking me the area. The area is given to you guys in the project. In this case, it's 40 square miles. And very importantly, you could add this, but it doesn't care. If it has a red star, you must provide the number. He won't run without it. Most important thing here is we want to define the methods we're using here. We're especially interested in a loss method, transfer method, and a base flow method. The loss method is the method that's going to go from rainfall to runoff. And the transfer method is going to go from runoff to a hydrograph, which is exam 2, all in a nutshell. Those two. And the base flow, we're just going to say no base flow for now. But it's where you could add base flow. So we're going to be using the SCS curve number method. And we're going to be using the SCS unit hydrograph method. And we're going to say no, none for base flow. So all the watersheds, we're going to be simulating with curve number and unit hydrographs. Because you guys know all about that. And there's an exam on Tuesday that's about those two. If I'm using the SCS curve number as a loss method, what is it going to ask me next?
Curve number?
Curve number. There you go. Right? Makes sense? Remember why I'm calculating S? There's an equation that calculates S. Remember initial abstraction, S, all that stuff. And effective precipitation, PE. That's what it's doing here. So if I move to my next tab, it's asking me what's your curve number. In the project description, I give you a land use and a soil type, so you can, and a table. So you go there and you find it. Does anyone have this? So do you want to find out what's the curve number for these watersheds? For now, I'm just gonna go with 80. 85, so we can move on. And then the transform method.
Well, for the curve numbers,
What? Why 85? Because I'm just guessing. Yeah, you guys are gonna find the right number. There's a table here.
and for the curve numbers, so do you want us to be on the conservative side?
So with this one, you'd have to take like an average of it, or?
I don't know, what am I saying? Fully developed urban areas, soil type C.
Okay, so when you go there,
Fully developed urban areas, soil type C. So you have some choices here. Yep.
so conservative, usually that's,
It's your choice.
I thought there was a way that you calculated for all of them, and then you took the average of all of them, or something like that.
That's within your sub-basic. So if here I have said 20% it's, you know, industrial, 30% is something else, that's you do the average,
Okay.
right?
Yeah. Okay. 'Cause I remember I did, that might have been first.
Yeah.
So we get the worst case.
You get whatever you want. So do we have a number? Let's say that number was 85 for now. You got, this is part of your job, to come up with a number. Yes? This is also part of exam 2, come up with a curve number. Seth Brown probably talked a lot about this in his LID stuff, choosing those. Okay. Now I'm gonna do a transport using the SES, yes.
Do you not need to put in for
0 is fine. What impervious is doing here is adding to it. So if you know you have a region of your sub-watershed that's impervious, you can see 20% is impervious and the rest is curve numbered, so and so. We'll go with 0 everywhere for now, because we're adopting curve numbers in a way that's incorporated that. Transform. So it's asking me what's my lag time,
75 minutes.
which is the result of that equation that had slope, and remember those?
Yeah,
What was it?
75.
75, okay. 75. All right, so we're done with subbasing A. We don't need any of that. So we're gonna go through 4 of them. So subbasing B is the same size, 40. And then I need to choose my method here. So SCS curve number, SCS unit hydrograph, no base flow. And then I need to go figure out my curve number. Let's say this is 95 and 0. And the lag time is given to
Still 75.
75. Okay, and then subbasing C is 60 square miles. SCS curve number, SCS unit hydrograph. None. Curve number now, let's go with 50, very low. And the lag time here is 420. So basing D, area is 80. This is all given to you guys.
800.
800?
I'm sorry, 8. I was reading the log down.
So I'm just choosing my methods here. If you're decided in the future that you want to use a different method, you can just come here and choose. Let's say you want to use the Smith per lunge method for, yes?
Some of the curve numbers, like cultivated, if you go across and it gives you like an average impervious percentage, can you put that in there?
You could, yes.
Okay.
But this is to give you an idea of choosing the method. That is different though. What that is doing to you is it's cutting your watershed here and saying 20% is completely impervious. And then I'm applying the curve number to the rest of it. In the table, it's giving you some guidance to choose a good curve number that represents the overall thing. Does it make sense? Okay, so be careful with that. was saying, okay, if you want to use the Smith per lunge method instead of the curve number method, I chose that. I go to losses. It asks me for all this, all the way to bubbling pressure. I have no idea what that is. So your choices have consequences. If you want to use a given method, you better understand what it is doing and have information for it. I've never used this method, so I don't know. But if you want to go with it, you need to figure out all of that, otherwise it won't run. Why? Because there's an equation underneath that needs those parameters. So I'm going to go back to our SCS curve number, which we're familiar with. And then it's only asking me, what's your curve number? And for this case, I'm going with 90. Now I'm guessing curve numbers here because I'm taking for granted that you guys are well versed on going to that table and getting that number. And that you need that for the exam. So if not, make sure you go through that exercise. And the lag time is given here, it's 800. Okay, so we have data for all the subbasins, right? We also need data for the reaches. So I'm going to go to reach 1, and it's asking me, what's the routing method we're using? What was the routing method we learned in class?
Muskingum?
Muskingum. So here it is, Muskingum. All right. So what do you think is going to ask me if I go with Muskingum?
K and X.
K and X. There you go. You guys are getting good at it. K and X. So 7
and 0.4.
and 0.4. That's all we should need here. Reach 2. Same thing. We're going to go with Muskingum. And then 8 and
0.3.
0.3. Could X have been 1.2? No.
No, I can't go above 1.
It can go. So those are the kind of things you want to remember. Okay. All right, so we have our riches. I think we have everything we need to move on here. So what we just did is we got our watershed in our model. Every characteristic we needed to run the equations you guys learned in class, it's here. Okay? Questions? No? So what would be the next logical step? Precipitation. Let's put some water in the system. So we're going to go back to components, and we're going to add a meteorological model manager. And I go with yes, give me a meteorological model, and I'm going to call this Met1 so that should have given me meteorological model. There it is. So here it is, and here's where I can set up my meteorological model. We also wanted to add an actual rainfall event so we can run our model. So I'm going to add a time series. And I'm going to add data type precipitation gauges. So we have measurements, let's add it. So I'll call gauge 1, that's fine. I'm happy with that. But I'm also going to add a discharge gauge, which is measurement at the river. So I'm going to add a discharge gauge as well. All right. So I should have now 2 time series data files here, 1 for precipitation, 1 for discharge. So for precipitation, I'm going to come here into my gauge. And I'm going to say, yes, I'm going to do it incremental inches every hour, because that's how I gave you the data. And I click here, and I have the data for 14 hours. You can see there's a date here. You can be precise with your date or not, as long as you're consistent. So in this case, I have not given you which date is it. So if we're starting January 1st, 2000, that's fine, as long as we run the simulation for January 1st. Does that make sense? Okay. So we don't have 5 days, we only have 1 day.
14 hours.
14 hours. And then I can go here to my table and I can manually enter these numbers. So 0, 0.5.
Oh, the 0 has already been taken into account.
Oh, is it?
Yeah,
Yeah.
because it starts out.
So there's data on an Excel sheet that you posted for project 2, and then there's the data on the Word document on project 2.
Yes.
Do we use both, or we're only using the
Well,
Word
the
document?
Excel sheet is
We're
for the
using
gauge.
both because here I'm adding my precipitation data. And I just put my Haito graph. The Excel data, it's for your flow. So that's the next thing I'm gonna add. So I just added the precipitation data. Is this clear? Are we all happy with precipitation data? Yes? And if I click on graph, I can see it. You should see something like that. Your Haito graph, right? Okay. So now let's use Excel data that everyone wants to use. Here it is. So discharge gauge, gauge 1 is my stream. This is what the data looks like. That I gave to you guys on Blackboard. It's just a time series of flow. And it's every hour. So I can just copy and paste. But it's every hour, so 1 hour, it's in CFS. Okay, that looks good. Expand, click here, every hour. Let's see. Yeah, looks great. Here's my hydrograph. So the hydrograph is what I measured here. Is the rainfall that fell over the entire watershed. Does that make sense? Okay, so I have my data here. I'm gonna go back to my meteorological file. And then I need to say none, specify hydrograph, none, okay. I might have an older version. This is a thing you wanna check, where it says replace missing, set to default. If you leave abort compute, it might crash on you because you don't have enough rainfall to sustain the period. So set to default. And then I'm gonna go to basins, and I'm gonna say, yes, please include my sub-basins in my precipitation. I'm not sure if I need to change this. I'm gonna leave it no. Let's see if it crashes on other. And then if I go here on my specified hydrograph, I have my sub-basins and I have my gauges. I could have had 5 gauges, just like you guys had for the GIS project. And you want to assign a different sub-basin to a different gauge, or a combination of those. Or if you're doing the real deal, you probably have 20 gauges and 400 sub-watersheds. So you might want to assign things to each other. In this case, we only have 1 gauge. So every sub-basin is going to get the same rainfall amount. So instead of none, I'm going to say gauge 1, gauge 1, gauge 1. Yes?
So in the case that you
You're looking
have,
for phasing out people here.
so in the case that you have, let's say 2 gauges assigned to sub-basin B, then would the program give you the option of adding 2 gauges?
Yes.
Oh.
Or, well, you could have chosen to use a Thyssen, for example.
Oh.
Or you can even use gridded precipitation, as you had. Okay, there's one more thing I forgot to do here is, we need to locate where our stream gauge is. Our stream gauge is at our sink, at that bridge. So I'm gonna go to my sink, options, observe flow, gauge 1 stream.
So you just
Sync.
clicked on sync?
Click on sync, starts off here, there's nothing downstream, we're happy with that. Options, observe flow. I added my gauge 1 to it. I'm just assigning gauge 1 to it. I'm gonna change one more thing, but I think this is because I have an older version. I click on my basing. At my basing, I'm gonna say replace missing yes. I don't think you need to do that in the new version, but it is what it is.
What does a replacement mean?
It means if you have missing values, like our precipitation only go for 14 hours, and if we want to run it for 5 days, it would just 0 hours.
Zero.
Questions this far? All right, so let's try to run. The last thing we need to do here to be able to run is to set up a compute run. What the compute run does, it brings the pieces together in order to run a simulation. So there's control specifications manager. We're going to go with that. And create a new one. Control 1. That's fine. Where's my control 1? Here it is. So control 1. What's asking me? What's the start date? What date should I use?
The very beginning of your data,
The what?
January 1st of 2000.
January 1st, yeah, that's the, just because I'm using default, but you're welcome to change if you want. What happened if I put 2015 here?
15 years.
It would try to run for 15 years, yes.
Yeah.
And it will do so because I said replace missing, keep going. So, sure. If you start in 2015, you won't find any rainfall, so there's no water coming into the system. Right? And the time interval here is the time step to which we're going to run this. I'm going to try 5 minutes to see how much stability we get. And I guess I'm going to save it. And that's all there is to it. The next thing we want to do is create a compute, and we're going to create a simulation run. So compute, create compute, simulation run. So it's asking me what's the name. I'm going to call run 1. Let's just call run 1 for you. Run 1. So it's asking me which basin do you want to choose from. I only have one, so I don't have a choice here. So I said basin 1, yes. Which meteorological file do you want to use? I only have one, so I don't have a choice. And which control file you want to use? I only have control 1. So it's not like I have many choices here, but we will soon. So this is where we put the pieces together. So I'm going to say finish. Once I say so, this little icon here should have been highlighted now, over there. It's like an explosion, fireworks with a little drop of water. Here's where you put all the energy you have here, you know, do whatever magic you want to do, and you click it, and you want to see this thing goes through and get a result. If not, there's a problem. So let's see for us. So close. Okay, so it worked. I got a bunch of warnings, but no errors. So we can live with warnings. We can't live with errors. Errors mean it's going to crash, so no results. Warning means you went through, but you should pay attention to whatever it's telling you. So here we got no problems. We have one missing or invalid values for gauge 1. That's fine. And then we have a lot of missing precipitation. We knew that because we only had 14 hours of precipitation, right? And we're trying to run it for much longer. Okay. And it's telling us that the Muskingum routing is unstable, so we'll see that. Let's check that. Okay, so how do we look at our results? we're gonna change tabs here and we're gonna go results. Here, that was components, this is results. Okay? And here's my simulation run. I have run one, I click on it, I get all my elements, and I also get a global summary. So I can look at the results per element, or I can look at the final thing. If we wanted to see what's going on at our bridge, I go directly on my sync, I can look at a table, but the plot usually tells the story better. Blank means measure data. That's what we measure. That's the time series we copied from Excel. That was our initial hydrograph. This means our blue means our final result at the sync. And the other two are the combinations of what?
The reaches.
One reach and subbasing D. Because that's what's coming in the sync. Subbasing D plus what's being routed through the reach. And here's where we're getting some instability here. Does this make sense? Yes? So we can explore the results per subbasing. So if I go to subbasing A, here's my rainfall runoff response. That's the rain. That's the flow. That's what's coming out, and that's your infiltration right there. If we look at subbasing B, same thing. Less infiltration now because I changed the curve number. Those were different. And if I go to my reach, that's the routing. That's the masking up that we did in Excel. That's what it's being done here. And that's your numerical instability right here. And that was my warning. It kept going. It wasn't enough to crash the system, but it kept going.
Was that because of what you guessed for your curve number?
No, this is my X and K.
Oh, okay.
This is routing now. So I have a model that runs, right? Are we happy with our model? How do we know if we're happy with our model or not?
We need to compare it to the measured data
Yes. So where is our reality check here?
at sync.
At the sync. So here's my sync, and here's my reality check. So our model is able to, even with instabilities, it's able to represent the peak flow really well. Do you guys agree with what I'm saying?
Yep.
So if we're mainly looking at peak flow design for this bridge, we're happy. We matched what it was measured, right?
So the black is what we actually reported,
Yes.
and then the blue is
What the model is
modeling
telling.
it based on breakdown.
Yes. Yes.
No.
The other ones are the components that are making up the other blue, which is the routing, the reach to, and the rainfall runoff resulted of subbasing B. If you add the two dotted, you get the blue.
So okay. Now let's
So if
say
I look at my summary table, it should tell us what's the peak discharge. Peak discharge for my computer results, peak discharge from my observed hydrograph. I guess I guessed really well at this curve numbers because I've never seen this thing work so well. So if you guys wrote that down, that's a good one to go with. And it's also giving you some error statistics between the two. The next step here is to calibrate our model, which means we want to make sure that the blue line matches the black line. So now it's time to go back to your model setup and refine your curve number. And you can also refine your X and K, because those are the parameters we're choosing. Even your lag time, we only chose 4 things. So we're using a 4-parameter model here to calculate runoff, right? Those are the only things we change. I mean, you won't change your watershed area. So we could change those 4 by a little more, a little less, rerun it, and see what you get. You should be able to change those a little bit to get a better graph. Okay? Is it clear how to do that?
So then, to know how accurate we are with our calibration, we're supposed to be comparing those two peak distributions?
Yes.
Okay.
So the blue and the black should be really close.
Yeah. Well, you can see here that our water is going out quicker than the actual measure data. See, our blue here, our watershed is draining too fast. So we have this weird behavior here, but it catches up. So we might be happy with this, but then it's draining too fast. So you want to increase the retention of water in your watershed a little. In terms of peak flow, we're doing really well. So your curve numbers might be okay.
So are you saying X and K need to change then, I guess? Or is it?
Yeah, you could work a little bit over on your X and K and your lag time.
Okay, so like,
Lifetime shifted, right?
Yeah, you would. Actually, this is a really good exercise to change these parameters and see what happens. And I would also change the curve numbers a little bit to see what you guys get. Okay? Yes? You do it? Yeah? Okay.
that's all it's to?
Huh?
That's all it's to the project, I guess, project is?
Okay, okay, so that was, here. We've set up a model, and we,
Calibrate.
well, I didn't, but I told you guys how to calibrate the model, right?
Mhm.
Okay, I'm just assuming my first trial here was good enough. I want you guys to work on it a little bit, at least have a couple of trials. Is it clear to everyone how to calibrate the model? And how are you gonna tell me that's better than what you had before?
Showing that.
Showing that, or that table. And you might want to note, I started with this is what I got, I changed it this is what I got, therefore it's better. Or I could never improve from my first guess, therefore I'm back to my first guess, which could have been this. Yes? Okay. Yes? So this is done. Okay. All right. So now we're going to go back. I'm going to close all my plots. And I'm going to go back to my components. And we want to use this for design now. Because all we've done is set up a model that kind of replicated reality. We really wanted to do a design. So we wanted to do a 100-year design storm, for example, for this bridge. How would we get that design? How do we get information for that?
So we grab the IDF curve,
IDF curve,
we get an
exactly.
intensity,
Get the intensity,
and then we can
duration.
use the
That
head press.
here.
Yeah.
Exactly. So I'm going to create a new meteorological model now. So new one. I'm going to call Met1 design 100 years. So now I have a new one here. I click on it. Instead of using a specified hyetograph, I'm going to use, guess what?
SCS storm.
SCS storm. All right. No. Keep going. I want to include my basing one. Yes. So what did I did here? SCS storm, none. And we're going to use inches. And yes, please include sub-basing one. And then I have here is my SCS storm. You guys see it here, SCS storm? So if I click at it, what is it going to ask me?
Intensity.
My intensity, or my actually total volume.
Depth, yeah.
What are the options of my methods here for my SCS type storm?
Type 2,
1, 2, and 3. So I'm going to go with type 2. And we would go into IDF curve, given duration, calculate a given inch. So I'm going to go with 9.2 inches. Don't do your project with 9.2. I'm just randomly saying 9.2. You're going to go here and you're going to get the right number. Okay? Do you all hear me or you're phasing out? That's the important part where you want to change. Yes? You have no hair now? Was it my fault? No, right? No. Okay, what was the name? Okay, we're good to go now. There's one last thing I want to do is I'm going to go to my sync 1 options, and I'm going to say no observed flow on my sync 1. The reason for that is we already calibrated our model. We're happy with it. We don't need to compare it to this anymore because that was a particular event. We're doing design now. So our design now is based on statistics. It's based on a given project design, okay? All right, so I'm going to save it. Questions so far? No? You good? Yeah? So I'm going to create a new compute, again a simulation run. I'm going to call this run to design 100. I'll say next. I only have one choice of basing, but now I have 2 meteorological models that I can choose from. Which one are we using now?
100 years.
The 100-year design. So it's already there selected for us. I only have one control. It's going to run it for 5 days. I guess we're happy with that, right? Let's see what we get. Okay, so I have this ready to go. Compute current run. So I'm running run 2. It worked. My masking goes a little unstable again. We never. Yeah, I think we're good. So let's go see it. So here's run 2 now. Run 2 design. Let's see what we got in our sync. So here's our final design. We're still getting this weird instability, so I highly encourage you guys to check your XM case, see if you can get rid of it. But here's your final design now. So here's your peak flow for 100-year designs for that bridge. And if you want to get the specific number, you can get the summary table. Here it is.
You don't have a black line because you didn't actually, so it didn't occur, so you didn't measure it.
Yeah, of course, yes. And I specifically remove it. Otherwise, the black line would be here, but doesn't mean anything.
Where'd you go for that again?
Which one?
The summer two, you just clicked on summer two?
Yeah. And if you want to get this time series out, you just click on time series table. There we go. Here's the time series table. You get the entire thing. And here's your outflow. Here's your combining flow and things like that. So we're around 55. That's what it was.
Would your meteorological model also show
56.
would that meteorological model also show your hydrograph for the SCS thing too?
Yes.
If you click on it?
Yes. Yes. There it is. That's for subbasing 8. Now there's something funky going on here in my model. And I wonder why is that? Can you guys see it? So when I looked at my subbasing A plot, I had 60,000 CFS coming out of that subbasing, right? When I looked at my junction 1, I had 130-ish, which makes sense because it's subbasing A and B together, right?
Yeah.
And then reach 1 should be routing all of that, which kind of is, so my 120 is here.
It's
And I'm
routed.
losing a lot of water here because of my instability. and it's only putting out 50,000. That's not good. So you guys want to check that, because we're losing water here because of this numerical instability. That's what I want you guys to play with and be aware of it. That's where you start to think about these things. Okay? Yes? Or no? Did I lose everyone here? Okay. So that's our calculated design. The last step, it's going to tell you, you know what? You have your design, everything is great, but your dear friend from school went and changed the link over all over subbasing A. And your curve number, instead of being 80 now, it's 98. What's the impact on your design? So you would go to subbasing A, and I can't remember what I said here. Maybe I said something else, but there's some story like that. And then you go here. Instead of 85 now, it's, let's say, 98. So you go here, you change it, and you should be able to just run the same run and see if your results changed. So it's 58 now, it was 56, so it increased by 2,000 CFS. Do we care about that or not? Then it's your decision.
Your judgment.
Yep. Okay, we got through the entire thing. Did it make sense? You guys feel comfortable using HMS for hydrologic engineering design? For those of you that, at least those of you that paid attention, do you think you can repeat that? Yes, right? For those of you that are on your phone, is your friend going to do it for you? I guess you are, right, Frank? You're doing it for him? Okay. Me? You're doing it for him, right? No? Okay. You don't care, right? Okay. You didn't even realize that. That's fine. Okay, this is as far as I wanted to get with the model. These models are really handy once you understand what you're doing. So if you're comfortable with the SEIS method, the rainfall runoff transformation, the routing with the masking gun, everything is straightforward and it should be easy to use. When this becomes really, really helpful is most likely in reality, you're not doing 4 sub-watershed, you're doing 200, 400. So this becomes really, really handy. This is one of the most used engineering software in water resources engineering, if you will, for rainfall runoff. HEC-HMS, widely used. Every engineering company across the country will use it. It's also used internationally as well. It has several methods here that you will never use. Others you might. For sure you can use what you've learned. What we're doing here is the most common design procedure that you will see it. There's only one caveat here, that it will come if you go to a grad class. Where do you come up and how do you come up with those 4 numbers that I'm giving it to you? We heavily rely on GIS for that. That's why everyone talks about GIS in water resources. All the delineation, all the model setup that we did from here to there can be done with our GIS. So there are tools for that. So that's where you come up with your model setup. Once you have your setup, you run it here. And that's how we do design. So with this, we're kind of closing a cycle here where you've seen the theory, the concepts, the equations, and now we have a tool that will do everything for you without you touching any math. As long as you know what you're doing. That's why I kept saying, check your concepts, check that you understand. Because when you get here, it's more about understanding than solving the math, as long as you understand what's going on. So this is project 2. I think we're going to finish class early today. This is all I have for today, but questions, and let's talk a little bit before you all rush out. Yes, Evan.
Can we get set dates for project 2 and
Yes.
1D?
Yes, let's do that. So why don't we define dates? Let me go here to our... So I guess I'm gonna remove
The extras.
the extra ones, and I'll just keep the latest. Is that the correct one?
No, I don't think any of them are
I don't.
truly up to date.
Yeah, I don't think it was.
Let's see what we have. We have time.
Not this coming up now.
This is the very first one.
We've already turned in homework 7.
I would think this is the latest one.
Yeah, that's the
Yeah.
latest.
That's the latest. But you changed when project 2 was due.
Okay, so we are right here.
And when the exam is.
We are on HMS, 1117. Okay, so that's okay. Exam 2 got switched with the flood management class on the 24th, right?
Mhm.
We all agreed with that. After Thanksgiving, we're rolling with project 3s for 3 classes, and then we have exam 3, which hopefully very few of you will take on December 10th. We still had a reserves class for the exam date, for the finals, that we're doing great, so I don't think we need to go there unless you guys have a suggestion or something, or welcome to James.
So are we gonna keep project 2 to be due on the same day as the exam?
No.
No, you said it was.
Yeah, so that's where we're changing now. So let's have project 2 do with project 3, December 1st, would that work?
Yeah, that's what you said.
Yeah, would that work for you guys?
Yeah.
Okay, now homework 8 is due Thursday. I can still accept homework 8 with the
With the exam.
before Thanksgiving, that's fine. But I'm thinking everyone finished homework 8 already, so you can turn it in as soon as you want. If you haven't, you're now joining the club of those that never measure rainfall and you're hoping for rain in the last week. And there's a even stricter club that is the ones that are hoping for rain the night before. And you'll be surprised how many members that club has. It has worked in the past, but it does not have worked every semester. So it's a mix of happy members and unhappy folks in there. I would not try to be a member of that. Try to finish that as soon as you can.
Wait, so are you saying it's this Thursday or the day of the exam? Are you saying it's the 19th or the 24th?
Okay, so we're saying that 24 for homework 8. Are we happy with 24 for homework 8? Okay, so the conclusion is homework 8 is due with the exam. And project 2 is due with the first day of presentations on project 3.
Can you put a list online so that way we know when we're presenting for sure?
Yes, and I have a list. And okay, project 3, guys. I can't stress that enough. Please don't be the one that gets embarrassed and remember for the rest of the college that you came here and embarrassed your entire group. You can't escape that. You need to come here and give a nice presentation. Everyone is watching. It's one of the most important part of the class for me. People hate it. You're in the spotlight. You get really anxious, but it's part of your job. You can't avoid it. You're gonna have to be able to speak in front of clients, and speak in front of the county, the other engineers, you name it.